Hi, this is Bryan, and I'm going to do graphic systems of equations. Yeah, so this is graphic systems of equations. Enjoy. We need a graph for this. So these are the three kinds of graphing systems of equations. There's one, which is when it has one point where they attach the two graphs attached to each other. Infinitely many, where there's actually another graph within on top of that graph, so that means the points are everywhere. And then there's zero, which they don't connect at all. So now you know, so let's try. So let's do this one. What is the solution of the following systems of linear equations? Okay, so since it's y x minus 3, we start at negative 3, which is there, so we just go up one, right one, and then we got that. So next, 2x 1 plus 1. So we start at 1, and 2x equals up to right 1, so it becomes that. So that means if you connect them both, the solution is negative 5, 8. So this is how you do graphic systems of equations.
Hi, it's RJ. So I'm going to do solving system of equalities. Solve the first system of equality by eliminating 2x and solving for x. Then, once you find x, plug in the other equation and solve for y. And then write your x and y values in ordered pair.
I'm Lindsey. I'll be teaching you substitution. Let's get started. But first, here are the steps to solving substitution. But this is also known as solving the systems of equations. Okay, so you just read the steps. We won't have to do the first step because we will already be given one variable equals. Our equations will look like this. Here's an example, and it's just a random one. Here is example number 1 in your two equations. X equals 4y and 5x minus 3y equals 17. So what you want to do is you want to put 4y into where x is because that's the value of x. So you'll be ending up with that. Then you want to distribute to simplify, and you'll be left with 20y minus 3y equals 17. So then you have to combine like terms, so 20y and negative 3y, and that's 17y equals 17. And then you have to divide on both sides so you can isolate y, and y equals 1. So then you got what y equals. Now you have to figure out what x equals. So all you have to do is plug it in. On this side, you have to rewrite the second equation, and then just plug in what y equals. 4 times 1. X equals 4. And then your solution is 4, 1. Here is example number 2 in your two equations. We want to plug in 2x minus 1 where y is. Then you would be left with this. 2x plus 2 parentheses 2x minus 1 equals 22. Then you want to distribute, simplify, and you'd be left with 2x plus 4x minus 2 equals 22. Then you want to combine by terms, which would be 6x minus 2 equals 22. But add 2 on both sides because you want to isolate x, and then you would get 6x equals 24, and then you divide by 6 to isolate x, and then you get x equals 4. Now the other equation, it is y equals 2x minus 1, y times 4, 2 times 4 minus 1, 8 minus 1, y equals 7, so your solution is 4, 7. And that is all to solving systems of equations. Remember that this is called substitution. The end.
Real-world systems of inequalities and real-world systems of equations. Let's start with real-world systems of inequalities. Number 1. A high school drama club put on their annual theater production. There is a maximum of 800 tickets for the show. The cost of the tickets are $6 before the day of the show and $9 on the day of the show. To meet the expenses of the show, the club must sell at least $5,000 worth of tickets. A. Write a system of inequalities that represents this situation. B. The club sells 440 tickets on the day of the show. Is it possible to sell enough additional tickets on the day of the show? First, you have to underline the important information. Maximum of 800 tickets sold for the show. The cost, $6 before the day of the show, $9 on the day of the show. The club must sell at least $5,000 worth of tickets. Second, you must write a left statement because the problem doesn't give you variables to write in for the answer. The left statement shows that x equals the number of tickets before the day of the show and y equals the number of tickets on the day of the show. Now write your equation and plug in 9 and 6 where they belong. For the first inequality, you have to plug in $6 for x because that's how much money the tickets are before the day of the show. The same goes for the 9. That's how much the tickets cost the day of the show. It has to be more than $5,000 because that's at least how much they have to earn or sell for their tickets. The second inequality shows that both number of tickets have to be less than 800 tickets because that 800 is the maximum number of tickets they have for the show, and it can't be higher. And this is your answer for the part of the problem. Now for part B, you want to do what we did for the first problem. So you want to underline the important information, which is the club sells 400 tickets before the day of the show. This means the new x value is 440 tickets. Now plug that in for second inequality and get your answer. Now you have the second inequality by plugging 440 in for x. After you solve, you should get y is less than or equal to 360. Now plug in what you got for y and x in for the first inequality. After you solve, your answer should be 5,880 is greater than or equal to 5,000. To take your answer, you would put, yes, it is possible because they sold all available tickets. They would make $800 more than they needed.